We have Mr. Avinash Kate, who is the Deputy Municipal Commissioner, Environment and Climate Change Department, Brihan Mumbai Municipal Corporation. We have Mr. Irfan Kagzi, who is the State Nodal Officer of the National Clean Air Program at Gujarat Pollution Control Board. Ms. G. Rajeshwari, Nodal Person, Head, ICCC, Greater Chennai Corporation. We have Professor Gufran Beg, Chair Professor, National Institute of Advanced Studies, IISc. We have Ms. Laila Surut, Director of Strategic Partnerships at World Resources Institute. Dr. Sarat Gutikunda, Founder Director, Urban Emissions Info. Dr. Vikas Singh, Senior Scientist at the Commission for Air Quality Management. Dr. Sumit Sharma, Program Officer, UNEP. Ms. Namita Gupta, Founder and CEO of Airweather. Mr. Sriram Manogaran, Portfolio Manager Data at Clean Air Fund. Dr. Abhinay Sekar, Consulting Research Fellow at Health Effects Institute. And Mr. Nimish Singh, Fellow Air Quality Research at TERI. Welcome everyone for the session. Thank you for making time for this. Today's discussion will be moderated by Dr. Prakash Doraiswamy, Director Air Quality, and Vandana Tyagi, Program Manager Air Quality. To start the session, I'll invite CEO WRI India, Madhav Pai, to deliver the welcome address.
Thank you very much, Prash. And, I'm going to say something that I've learned over the years from people like Sarat and others. So, I think, but it was very interesting. I think it was maybe Subbu at C-Step who said it like this, but I found it very sort of impactful. He just said, the challenges with air pollution is, and when you come to data, it's not just one source, not just primary sources, right? So, so source is a problem. Emissions inventory can tell you about emissions, but not where it came from. Source apportionment can identify and quantify, but can't tell you the location. So you need modeling at the end of it. And I think, and of course, satellite also, does not necessarily provide the nighttime view of the. So the fact that, you need modeling to do anything, that is. So it becomes very important. As soon as that happens, then you need really, really this sort of. So it clearly lays out the multidimensionality, multisectorality, of the problem, and that you need some data standards, data standardization to happen for us to be able to make progress. And so I think it's great. I think for a session, I think as a team, I think last 2 years, we have also been, working. We as WRI in a big way only started working on air pollution about 5-6 years ago. But last 2 or 3 years, we've really focused on working on a few sectors and really being able to create ground level data, right? Whether it's on road dust management and a lot of it is on actually implementation action. So whether it's the methods that are used, whether it's waste burning and trying to sort of come up with methods to quantify the amount of waste burning in a town or a city, and then come up with scientific ways to solve it. We've been looking at construction and individual construction practice. So we've looked at a lot of micro actions and trying to generate data about it and bring this. But as we've been also working across sectors, I think we've been trying to see how, especially in some of the cities where we are engaged deeply, how can we bring a much more holistic approach? And I think it's very clear that, we need to be able to also, because it's a multi-sectoral problem, we have to rally a range of actors, whether it's industry, whether it's MSME, whether, especially to deal with very local level problems, whether it's a ward level action, a citizen action. And so it's almost like a 2-dimensional matrix where you're looking at sectors, you're looking at actors and trying to, and almost I think we believe in a way that I think data monitoring almost becomes sort of one of these actors in a way. And so how do we, really bring all the actors that work on data and monitoring? How do we develop standards, and how do we make sure that this becomes the base for a lot of the other actors to sort of work and, engage in all of the sectoral action? So I think with this sort of this approach, I think in pretty much in every city, how do we really create this data monitoring and also engage a larger community around it, and especially, and again, it doesn't have to be generically, it's really actors around specific problems, but and also be able to show progress. So I think that was sort of what I wanted to sort of say at the beginning. That it's a complicated problem. You clearly need modeling, you need standard inputs, and you need sort of people with expertise to be able to do it. So how do we enable that? And one last point I will make, I mean, and this is sort of a point that we've been talking also, that today the amount of expertise around this topic, or the number of experts that exist, are limited, relatively small. And if we can think about creating maybe small sort of and uh, uh, like centers of like expert technical or facilities which can help many cities with some of the sort of technical capabilities that are needed around data, that is also one of the solutions that can be explored, and maybe could be linked to a larger financing program like NCAP or others. But I think it's impossible to create very quickly capacity across all of the 120 or so non-attainment cities and others. So can we find the idea of creating some kind of a facility that becomes responsible for just really standardizing this whole data conversation, and also standardizing the capacity creation within the country around this data conversation. So these broad 2 points I wanted to make, and over to you, Prakash, to further carry the course. Thank you very much.
Thank you very much, Madhav. I think now we'll get started. So what I want to do is just kind of give some just a brief context setting presentation, and then we'll get into the roundtable discussion. Can we project the slides, please? So first of all, I would like to welcome all of you. We have kind of a diverse panel here. We try to invite people from the different sectors. Like Madhav said, this is a multidimensional, multi-sectoral problem. So we try to have the city representatives, the modeling group, observational, experts, as well as low-cost sensor vendors and funders. So we try to kind of bring together everyone. So when we talk about equality management as such, it's a cyclic framework, right? So you have this goal that's been set, whether it's the National Ambient Equality Standards or the NCAP. But then you use these, you assess compliance in current and future years, and identify mitigation measures, and then you track and evaluate it over time. So this is, and then accordingly, then you adjust what your goal is. But to do each of this, then to assess compliance, and you monitor air quality, you model for the mitigation measures, and you really design what these on-ground measures should be, you implement it, and then you assess it over time. So basically, it's not just one data point that helps, right? So kind of it's a busy slide here, but I'll try to kind of go through this. So we have these different types of observational data. We have the CAQMS, what's the regulatory monitor, continuous ambient air quality monitors. LCS, that's a low-cost sensors. Then we have the satellite data, and then you have the manual monitoring data that is filter-based. All of these form one set of observational data that is looking at the ambient air quality, what is measured in the outdoor air quality. Then you have another set that is the continuous emission monitors that looks at measures the emissions. And then, of course, then you have the meteorological data. So together, all of these form the observational aspect. Of course, the ambient data and the meteorological data together, you will need to look at the trends, analysis, hotspots, spatial patterns, temporal patterns, and of course, in conjunction with, say, chemical speciation and source apportionment. And more recently, now people are using AI and machine learning tools to really see if we can move towards a more of a real-time management. On the other side, where you have these emissions, that really feeds into understanding the source activity, but you also they have the source activity then that feeds into the emission inventory development. But where does the source activity come from? You have a combination of secondary data, that is, different surveys that's already being done. And then you have the primary data collection where there's a gap. And then all of this then feeds into air quality modeling. So you have this bunch of different data sets that really come together. But are we really effectively using these data sets together? How can we enable cities to use it for on-ground action? And so that is basically what we really want to kind of discuss in today's, roundtable discussion. Kind of briefly give a little bit of how we've been trying to do this in WRI India. This is an example in Indore where we developed this emission inventory For those sources where we did not have activity data, we conducted on-ground surveys using secondary data and on-ground surveys. And so this is an example of how we kind of selected representative villages and wards within the Indore Municipal Corporation and outside villages, and kind of did the collected data. I want to just show transport as an example. So just an example of the data that were collected in Indore. It kind of enables you to understand the mix of vehicles on the road, the fuel composition, the use of the distribution of fuel that's being used between commercial vehicles and passenger vehicles, and then ultimately we develop this emissions inventory, right? So for Indore as such, we find that, of course, resuspended road dust is a pretty big component, along with the transport exhaust. So together, transport itself, you're looking at about 70 to 80%, depending on whether you're talking about PM 2.5 or PM 10. But what I want to really drive at is, so when you have such granular data, much of it that it's not always available when you're talking about the activity data. So when you have such granular data, then you're able to develop these, you have this opportunity to design these mitigation measures. And so this is something like a suite of comprehensive mitigation measures that we developed that kind of tells how much emission reduction you can get depending on once a suite of measures are implemented. And likewise, how do you really kind of assess these happenings on the ground? So this is under the Akash program that we're doing. Example in Surat, where we assessed the waste burning that's happening on the ground, and the measurements actually showed a pretty significant reduction in the tonnage of waste that's being burned in Surat between 2019 and 2023. So this is an example of how data really demonstrates improvement on the ground. And this is something in Mumbai where we actually looked at the road dust. How long does it take for the road dust to build up? How efficient are the cleaning methods? The thing is, it really needs to be optimized. So there's no single answer, but typically you can see between 4 to 7 days, you kind of see the road dust starting to build up again. And then you have this, the efficiency also really differs. And we found this mechanical sweeper. So likewise, we also did some analysis of the CAQMS data, the regulatory monitoring data. Just kind of quickly, I'll run through this. This is for Mumbai data, where the data availability really varies by site, right? So this is with the one on the top, you have just about 14%, while the bottom one has about 31%, and that too, it actually that site has really high concentrations. If you look at the the skewed portion, concentrations going as much as 300, 400, and you're missing some data during the winter period. So it really goes to say how important it is to really ensure that this data is managed well. The data quality is also important. And this is an example of, so using the same data, what we see in terms of the exceedances in PM10. What shows here is the stations exceeding more than 50% of the days. So basically, the point is PM10 is a year-round problem. And for PM 2.5, it's much less worse when compared to PM10, and it's mostly a post-monsoon and winter problem. And I'll, this is a little bit busy slide, but I'll, just how do you really take advantage of this regulatory data and really, look at it from a fundamental sense. So what this shows here is the ratio of what we call as a PM 2.5 to PM 10. In other words, the fine particles over the larger particle size. And the larger that ratio, it indicates the larger contribution of combustion sources, anything that's burning fossil fuel. And the lower the ratio, it indicates more of, let's say, crustal dust types of sources, construction. What we find here is during winter season, where it's kind of highlighted by circles there, the oval, that is typically dominated by fine particles. So the common narrative that Mumbai air quality is poor in winter due to construction is not entirely true. There may be some sites where you're seeing, but that's not entirely, it's not universal. I think that's the point. So looking at data this way, you are able to kind of get these types of insights. And we also kind of supported the Chennai Corporation to kind of come up with some recommendations on how do you deploy a low-cost sensor network. So kind of going with a structured approach. We have team members here who really helped with that one. So basically, taking all of this and what I showed in the beginning, what is the current gaps and the limitations of the ecosystem? See, most of these air quality data, the activity data, they are either not available in the public domain or they are not standardized. it's limiting a national level assessment, right? And this emission inventory is static. It is a different time period. So we have 131 non-19 cities, but then each one has an emission inventory source apportionment done at different times of the year. If we are able to standardize, how do we, maybe that will help minimize the, or help actually enable a national level assessment. Data is not available in the public domain. The activity data are actually, collected, it's obtained from various surveys, and those surveys are actually not intended for air quality assessment. So it's not, how do you really effectively use that? And how do you really enable cities to go beyond just looking at air quality index? As of now, cities mostly look at these measurements, understand it from an air quality index perspective, but how do you really kind of move it forward? And how do you assess the impact of these policies that are there on the ground? And the data mostly looked at it's not looked at in unison, right? They looked at in kind of separate pillars. They really don't look at kind of bringing these data together. So that is kind of where we are currently. And so where do we really want to go forward? That is what we want to discuss here. So we'll just kind of open up for the discussion. I am going to switch over there. I was sitting here to just basically go through this presentation. But then we'll start with Abhinaya. So you have started looking at the NCAP data, and over the past few years, the air quality data. So what are the key insights that you've learned, and maybe share a little bit of the importance of data quality and the findings?
Well, thank you so much, Prakash. Can I have my slides here? So we have done an assessment. We have looked how the air quality has changed in NCAP cities. So among 130 NCAP cities, 102 cities have the continuous ambient air quality monitoring station. So we assessed different metrics, and we looked at what will be the right metric to show the air quality improvement. So what we noticed is that next slide. Yeah. So what we noticed is that since 2017, which is the baseline year for the NCAP, there was a tremendous multifold increase in number of monitoring stations, both for PM10 and PM2.5. And large number of station has come in the year 2023, which means the stations with long-term data availability is very less. Only certain cities have data to conduct long-term trend assessment. And also, it's not just the total number of stations which got increased, but also the data availability has got increased since 2017 to 2024. And stations that report less than 50% of data has reduced since 2017. So one big achievement of NCAP is that increase in number of monitoring station and also increase in data availability. Can I go next slide, please? So what we notice is that the data is available, but how far the data is complete is that we check. So we had a data completeness criteria which is very granular. That is, the station should report 18 hours daily and 23 days each month and 11 months in a year. So once we applied this data quality completeness criteria, the number of monitoring stations for the long-term trend assessment, it got shrinked. So this is because mostly it was because of the annual criteria, that is the 11 months, because the starting of the monitoring station, the year which started, it has less data. So if you look at this slide, maybe it is not clear. So the station reporting complete data for more than 3 years got even more shrinked, and the data reporting complete data for more than 5 years, which is, so the cities that is available to conduct a long-term trend assessment got reduced when we applied this criteria at each level. But we also noticed some interesting results. So this is the annual average plot we plotted using all the stations that met the completeness criteria for all the year between 2017 and 2024. And we saw a decline in PM10 level at the national level. But when we looked at the stations that reported complete data for more than 5 years, which means the complete data for a long-term period, there was no change in a trend. So it becomes visible that it is important to have a complete data for any kind of trend assessment, and also the data availability, as Prashant mentioned in his presentation. Like a lot of studies in India use this uptime filter of 50% and 75% for the trend assessment, which means a season itself is getting lost. Particularly in most stations, the winter season was getting lost. So that is why we used this granular data completeness criteria for our assessment. And one final thing which we noticed is that the number of stations above the national ambient air quality standards for PM10 did not decrease so much when compared to the baseline year 2017. However, for PM2.5, there was significant improvement in terms of NAC's compliance. So although the progress has been made in terms of PM 2.5, the revised NCAP target does not include PM 2.5 as a pollutant, as a targeted pollutant. And not just the annual NAC's compliance, even the NAC's exceedance days for PM 2.5 was fewer than PM10. So this becomes a strong case that PM 2.5 can be treated as one of the target pollutant under NCAP. Yeah, so these are our like key findings from the study. But we also looked at how the different metrics play while using this data. Happy to discuss and take questions as it comes. Thank you, Prashant.
Thank you very much, Abhinaya. I think it also kind of points to, the slides that you showed kind of really demonstrates the importance of data quality and how this ambient data will be helpful to really look at, trends and to see whether we are on the right track. So thanks for that, kind of setting the stage on where we are currently and how cities are doing. So maybe with that, I'll probably just start with maybe a discussion of how cities are handling at the moment. I'll turn it over to Sir Amnish Kate, sir. Can you maybe share a little bit on how Mumbai Corporation, BMC, is using the data-driven approach to address mitigation of emissions from sources, say, such as road dust and more recently bakeries that you've been targeting?
Hello. BMC is already using data-driven approach. We already have auto DCR for development planning and GIS maps for building permission, ward information, facility amenities. I was there in the sewerage operation department, water supply department. For a sewerage network, for a manhole, we have more than 28 attributes. So that kind of information is collected and is being utilized. So as far as the bakeries are concerned, these are unorganized sectors, and the contribution to PM 2.5 is around 3.5%, and with biomass burning, PM 10 contribution to the air pollution is around 11%. So it is एक बड़ा contributing part है bakeries का. So the code के direction भी है और MPCB से भी direction है कि we need to convert bakeries to a cleaner fuel. Initially we had been given timeline of one year, but subsequently it changed to 6 months.
So if you need to speak in Hindi, that is also fine, or whatever is comfortable.
नहीं ठीक है. So BMC ने बहुत बड़ा exercise किया है तो data collect करने में. तो all the bakeries, there were more than जितने भी permissions दिए गए थे, तो उसमें around 1,000 bakeries का data था. तो हमने जो check किया तो जो duplication है, many of them bakeries were closed because it is a kind of business that it is not continuous. Some bakeries were closed, some were duplicates. So we all have 592 bakeries in Mumbai. So, and some of them were using already cleaner fuels, just like LPG, electric. But with our effort from last October, some 84 bakeries are already converted or on the path of conversion. What kind of data we got is like ownership, location like slum, building, industrial area. the type of production, then fuel use, then number of ovens being used, shifts, then ventilation, air pollution control system used. And of course, when we did the survey, ground survey, we imparted then them willingness to convert to the transition to clean fuel. This database is regularly updated and monitored. And with this kind of data set, that is very useful to formulating specific solutions. Like slums, we cannot have PNG connection. It is very difficult. But they don't have option other than going for electric. And there is a regular stakeholder meeting because unless we solve their problem, it will be difficult for them to go for conversion. In the July month only, we had a meeting with Mahanagar Gas people, then the bakery association, and then the financing scheme. There is certain cost to it. Conversion of bakery has certain cost to it. This data also helped us in cost of conversion, then in what type of scheme they can fit into. We can give them certain benefits or financial schemes are also the central government, state government. So what type of financing schemes are better for them? Cost of conversion, cost benefit analysis, all this was helpful with this data we are having. So as far as the road dust and road dust is concerned, it is again 30% contribution to the PM10. Okay, so it is a major contributor. So in winter only we have to be very careful about it. Resuspension of air road dust, that is a big problem. So we are using water tankers, then misting machines and fire X machine and all other machinery. And there is a court case also going on. So we for that also we need to get our data ready. And wherever the pollution is more, hotspot is there, we need to increase our machinery. Deep cleaning effort we need to increase. So with the help of WRF, we had done silt load analysis. That is useful to manage the resources and again the water that is being used, because a lot of water is being used for this road cleaning activities. So that's all I want to say.
Okay. Thank you very much, sir. So I think basically you have to tackle this bakeries transition. It was interesting to hear about, looking at total systems perspective.
Yeah.
Looking at was basically understanding the sources that are there, inventory of the different sources and the fuel that they use. Interesting to hear that also about the cost benefit analysis in this. So trying to bring all the data together. So I would like to kind of switch to maybe Dr. Vikas Singh to share a little bit on how CAQM is looking at a data-driven approach to design targeted interventions.
Thank you, Prakash. So initially there were a few presentations where the emphasis of the data-driven approach was given. And the emphasis is on the finding the sources. So when it comes to air quality management, it is not only finding and identifying the sources, but also taking coordinated actions and enforcement, where also the data plays a very important role. Commission has already identified a lot of priority areas which are data driven. One of the things is the emission inventory. We have already identified the gaps in the previous emission inventories. The differences, we had the emission inventory over Delhi starting from Safar, then Terry emission inventory, then various emission inventories published by various researchers. And when we see that emission inventory there is no convergence on the common methodology. And then they were not in dynamic in nature. Their update cycle was not very well defined. So by constituting a expert committee, it was deliberated, and Commission has already devised a framework for the development of emission inventory, where we stress upon like data-driven approach, not only for the emission, but also from the activity level, from what will be the data source. Because as far as data is concerned, we have a lot of data in India, only the data is not talking to each other. So we have emphasized it is a way forward. We go, then also there is a lot of emphasis on the development of the emission factor. And then again, modeling framework is important for the identifying from where it is coming. As in the initial discussion, it was told that the source apportionment is measurement-based source apportionment has its own limitation. Emission inventory has its own limitation. Combined, the modeling is a solution. So definitely, the Commission also agrees for any policy making or any decision making, the model, which is again data-driven, plays very important role. In addition to that, we strongly rely on the coordination. In earlier discussion, in earlier session, Rashri Madam, she told about this command control for the coordinated actions. Because at the moment, what we are receiving data is like here and there, and then the data can be manipulated. Once we have interconnected systems, and then a single source data which is communicated to the various stakeholders, so that makes the data and decision making very easy. The third point where the data plays an important role is the enforcement and compliance monitoring. Already a lot of efforts are going on, but again, it is all set of data which is required for the air quality management. And then the fourth aspect is the which was missed in the initial presentation is the health impact studies. So we also need the this demographic data. Of course, for the emission inventory it is required, but when we talk about the whole air quality management, it is very well known that it is multi-sectoral. It is cross-disciplinary subject from all domains of science as well as social sciences. So this much amount of data is required. Now, what Commission is doing to integrate all this data, we are developing our own portal where we are trying to integrate all the data set from various stakeholders, from SPCBs, from ULBs. Many stakeholders are there. We work with more than 200 plus stakeholders. And then, so that will build upon decision making and the faster resolution of the problems. And I'm not going sector specific, because if I go sector specific, then it is very, very complex in nature. Okay, thank you.
Thank you very much. I think it's really very encouraging to hear the steps that CAQM is taking, and kind of really, I'm glad you mentioned about this health effects analysis, right? That is an important component that I did not mention initially, because we already have, there's so much to do on this emissions activity data itself, but I'm very glad to hear that CAQM is really taking that step forward, and also kind of looking at the demographics of it. So let's now switch to Mr. Irfan Kagzi of State Nodal Officer for GPCB, of NCAP for GPCB. So Gujarat Pollution Control Board has been a kind of a leader in implementing innovative approaches to tackle emissions from the industry sector. Can you talk about how GPCB is utilizing the data from the industries, say it from the SIMS, the continuous emission monitors, or fuel consumption data, to really understand their working operations, the patterns, the emissions? How is GPCB kind of interacting with the data sets?
Thank you, Prakash. I would like to start first the little background of the SAMs. See, initially there is a mandate for the red categories as per the CPCB to install the SAMs. So we started with the red large. There are the three sectors. If any industry is having plant machinery investment less than 10 crores, it falls under the small. If it is between 10 to 50, it will be medium level, and then above 50 crores, it will be a large scale. So those industries falling under the red categories are mandated to have SAMs at their emission points. Now the 17 categories are very well known to us. So mainly comprising of the cement industries, pesticide, pharmaceuticals, dyes, intermediates, fertilizers, etc. So again, if you are taking any industry, there are two sectors, utilities as well as plants. So continuous emission monitoring system is required to be devised at point source of utilities as well as the plant process plant. Now, what coming back to the question that out of the 17, almost we are continuously disclosing the data of the 17 categories. Almost 767 units have been linked with our website, and continuous emission data can be availed from our website. If you are clicking to our governance and clicking the data of GPCB website, you can avail the data of what these 667 industries are doing at point of time, and you can get the historian of that. So based on the availability of the data and their performance, we are accordingly, our regional offices are there, and based on that we are acting upon. So that to begin with, if any industry, we are not seeing the spikes of the non-compliance, but how many times it gets and how many times we are getting that spikes. Based on that, we are first starting with the letter of corrective measures to the industry, and based on that we initiate the legal action. Suppose after number of so many intimation, if that is not correcting, then we need to go and monitor in detail. So what is we are just trying to reach to the source of the problem. So what is whether their intent is not correct or there is something else. So based on that, we are going to inspect and to verify whether the performance of air pollution control device is not appropriate, or is there any other intention of the industries. So if at all we are finding, based on the last 5 years, we are also, whatever the legal actions we have taken, based on that we can determine that consistency of the compliance as well as the recent data availability on the websites. So based on that we are going to take the conclusion regarding the action. Number 2, fuel consumption of the data. So see, in our state, mainly based on the pharmaceuticals and pesticide industries, so hazardous waste was a problem. So initially when the rules under 2008 regime, there were hazardous waste rules wherein as per the rule 9 that it was entailing to utilize with the permission. So previously it was our experience that the hazardous waste was being not utilized properly, and it was being sent to some informal sectors, which was creating the problem of generating pops as well as so many things which was written in the chemicals. So the various sectors, to name the few, pharmaceutical sectors, API sectors, pesticide sectors, may comprising the halogens, was very threatening to the environment. Once it is mishandled by the informal sectors, engage in manufacturing of bricks people were utilizing that in place of the coal. So that was required to be stopped immediately. So before in the year 2010 or 11, we started one drive to have a meeting with CEOs of the cement plants industries in our state to utilize or to make common waste exchange back. So then we started to have facility of the pre-processing facility and co-processing facility to collect even smaller quantity of the hazardous waste was being collected by these pre-processing facilities, fixing the calorific value along with the other blends, and then it was channelized to the cement plant. So it was a win-win situation for that. On one hand, we were controlling the mishandling of the hazardous waste by the informal sector, and on the same thing, it was required to be incinerated. So in place of the utilizing the fuel to incinerate this, it was being channelized to the cement plant, where more than 3 seconds time, more than 1400 degrees centigrade temperature, and no ash generation was the result. And as far as the quality of cement was concerned, it was not being harmed by the utilization of the things. So by doing this, we are now we have got the very success in this, and continuously almost lakhs of tons of hazardous waste are now in place of the incineration. We are going to utilize and channelize to such cement plants. As of now, we have in our state 14 pre-processing facilities are there, and we are encouraging them, but with strict implementation. So encouraging the pre-processing facility is not the thing that is simply just taken through. The need of precise stipulation of the condition, erection of the plant, controls of VOCs, these are the aspects that is to be taken care of. So these are the things that we are going to conduct for controlling the area source and point source in terms of air emissions. Thank you.
Thank you very much. It's interesting to hear the how one waste is being kind of sent for use as a fuel, but at a higher temperature. I assume those industries also have appropriate emission controls to capture those emissions from those.
And more than this, actually, we have published this almost 6 to, based on our experience, our State Pollution Control Board has published 7 to 8 publications in terms of controlling and guiding the people. We have published the hot mix plant guidelines. We have published the spray dryer guidelines, which utilize the high COD, high TDS effluent. We have published the stone crusher guidelines. Then what sort of the utilities shall be having what sort of device and what capacity based on the suppose if you are installing the 2-ton boiler, 1-ton boiler capacity, so what sort of the fuel consumption, and accordingly what sort of air pollution control device shall be placed. That is available on our website. And newly we are going to launch the construction SOP PM 2.5 and 10 control measures on coming day of on 11th September. So these are our publication based on whatever experience we have gained during the last years.
Thank you very much. So I think we'll now move to Ms. Rajeshwari from Chennai Corporation, Head of ICCC. So ICCC, you have been bringing together different data sets for governance and decision making. If you could talk about two things. One, what challenges you kind of encountered when trying to bring these data sets together, and then what are you planning next for kind of expanding it to include air quality data?
Good evening all. Thanks for giving me the opportunity. And once again, I am saying that you are all very good knowledge about that AQI and environmental everything. But repeatedly, I don't want to say that everything, that technically how we are going to implement that. Once again, I am saying that whatever you want to do, that achievement, that ICCC is that step, and that is strongly I can say that ICCC is the very good platform to implement all that sensor. That is a unified data. This is our ICCC, Chennai ICCC, and just quickly I run through that because you might have seen that everything. So repeatedly, I don't want to see that just technically, just how we are going to challenge the data, what is the mitigation, how we are going to do that, all the mitigation part, just I'll go through it. That ICCC is a unified digital data platform. That is, it consists of all data sets. For example, solid waste management, stormwater drain, and mechanical, electrical, that goes on like that. And IoT sensors you have, camera feed you have, and GPS tracking system, and especially you will be having that public engagement system. This because we are the people to service for the public. We have to maximize the service to the public. So in that case, this is ICCC, it acts as a bridge between the city administrator, is it working? Is an administrator as well as city people. So that you always have to communicate with the people. So not only for giving the data. See, as an administrator, I know all because we are all well educated. We know all the values. How do you train the people? How do you react this people? That you have to see each and everything. So in that case, integration, that it is, what is it? It enables ICCC, it acts as a real-time monitoring, evidence-based decision making, and proactive governance. So that is proactively we can alert the message. One by one we'll see this. Actually in ICCC in Chennai, already we have initiated 18 environmental sensor across the Chennai, and we have all the parameter, we are receiving it, and we are giving the real-time feed and dashboard alerts. But frankly, openly I am saying that so far we have not come across the situation. Actually, now we are very strong enough in that disaster time, that flooding time, how to manage all this thing. So in that ICCC, we have created the impact about that, how to handle the disaster, that flooding, rainy season. So we have all IoT rain gauges, flood sensor, and so many innovation. Every year we are introducing new innovation. That this is what now that just like that, I have initiated that AQIL. I didn't know about all this thing. That day, Anisha and Sir has given lot of input. Then they have triggered me. Now I have involved in all this thing. Now I have taken charge of that R&D work also. So definitely, and next time when I meet you, I will introduce some new innovation. And the thing is, now we have got that after introducing that Anisha and Sir, now we are we have 18 sensors. Now we would like to have another 10 environment sensor across the city. So that is, I have got that administrative sanction also. Now is the floating time is going on. The process is going on. Within a short period, we will be implementing that IoT device, that low cost environment sensor. So this is what the basic structure, because all you know about that history, this and that. This is what that exact system technically. From IoT device, we are receiving that real-time data. That is, within every 30 seconds, we are receiving the data, and the data is authentication. The security is very, very important. So, through that API, that it integrates authentication, and it after the authentication, this data will be integrated, and it will be stored in our ICCC server. You may have that on-premises server, or you may store it in the cloud, and then it will be displayed in our dashboard. The sensor layer, various sensor, you may have that air quality, PM 2.5, PM10, SO2, NO2, temperature, humidity, and like that we have 17 sensor. And now what is it now? We want to customize the air quality, that air, wind direction, and wind pressure also we want to integrate. And not only for that, you will be having the sensor. Many people, OEM, I found many people, they are having that environment sensor. Now I want to customize it. I want to customize in a different method, because I have to attract the people. I have to give awareness to the people. So in the aesthetic manner, now we are going to introduce that environment sensor in Chennai city. And not only for that, it is available in our dashboard. How do you communicate with the public? So in this public, through the data, that is display, VMD display, various messaging display across the city, we are going to introduce, and already we have 100 VMD. Now we are going to establish another VMD, 100 VMDs. So through VMD, we can publish that current temperature, current humidity, what is that AQI value, whatever the wind direction, everything, wind pressure, everything we are going to introduce it. And apart from that, we have PA system also is there in smart pole, that various components connected in smart pole. Here that we can, the crisis time, when you feel it, you want to, the commissioner, the city administrator, he wants to say something to the public. So in that case, they can use that public announcement system also, one-to-one, one-to-many. In that way, we can give that better servicement of the public. So in this case, integration, so many things are there. I think the time is okay. That choose based on refresh. The thing is, security is very, very important. How you have to see that, because it is the ICCC is the data monetization. That case, you have to see the securities in various level. Then how, because data sharing, various department, you are going to share the data to various department. And other side, you are going to receive the values also. In that case, you have to concentrate on the security level. Technically, you can talk to your technical person. So ask them to take the measurement of this. And this is, what is it? I've gone through. And the challenge is, this is, how do you then, environment sensor, I think you might have seen that in AQI, to find that AQI value, the people, they may taken it away, no, without the thing is. So in this case, what all the mitigation, I have explained everything. I think there is no time for this. Install tamper-proof evidence, CCTV coverage also, you can have geotag assets, you can create a asset, so many things you can do. And network connectivity security also, I think so many things are there. I don't know whether I can cover it or not, but I'm not going to take that much time. But I'll deliver that, this is that I have prepared for my own purpose. Even if you want, you can take it the presentation, you can show it to a technical person in your city, ask them to establish that AQI, environmental sensor. It's highly useful for that. So in that way, you can create the impact of the AQI value, no? Because Delhi is already polluted. But frankly, openly I can say that in Chennai, we are not bothering about it. Only during the Deepavali festival or some other occasion, we just will look after the thing, all this thing. But anyhow, proactively, we can initiate the process in our Chennai city also. Even if we want, we can share all the data. We can communicate with each other city. Then we can bring a better service to the public. Being a government organization, we can do a lot of things. New innovation we can create it. Thank you so much.
Thanks, Rajeshwari. So it was a wonderful discussion what we had, and really it's important to have integrated data. So moving forward, I like to ask Laila. So you have a vast experience at the international level, and so from that perspective, I want to understand that historically speaking, how can you, can you share how air pollutants data, it plays a key role in policy and decision making? And do you want to share some examples that, demonstrate the need of the comprehensive data driven approach that brings into account multiple perspectives, technical, financial, etc.?
Thank you. So is this on? Is it on? Yes. Thank you so much for the invitation. It's really a pleasure to be here. I'm based in Washington, D.C., and I now focus a lot on climate issues, but I started my career at the U.S. EPA for 7 years working on implementing air quality standards and regulations. So this is really, truly at my heart. And I've loved this discussion about the need for all of these different types of data to come together in order to have effective air quality monitoring and mitigation measures and an overall program. I've seen firsthand how integrated data systems are the cornerstone to developing these effective air quality programs. And most importantly, these integrated data systems are critical to understanding the public health benefits. So it was very interesting to hear, Prakash, you mentioning that on your slide with all of the different sources of data and the uses, that you said there was an omission of the public health impacts. And for me, I sort of feel like that's the beginning point, because ultimately it's about getting the political will and it's having the public understanding. So you don't have political will until you have the public understanding. And the public, they may or may not understand air quality, but they understand their own health. They understand asthma. They understand how the poor air quality affects them personally. And so 30 years ago, the U.S. faced air quality crisis. Cities like Los Angeles, Chicago, New York had hundreds of days every year where they exceeded the ambient air quality standards for one or more criteria pollutants, including ground level ozone, fine particulate matter, and exposing millions of people to unhealthy air. And this air pollution was linked to rising asthma rates, heart disease, and premature deaths. And it's this health crisis that created the political momentum for action. So EPA strengthened the air quality program based on the integrated data ecosystem, which includes the ambient monitoring, which includes the emissions inventory, and which also included the health studies to tie public health data, for example, hospital emissions, asthma attacks, cardiovascular disease, and premature mortality, connected that to pollution levels. And this sort of multi-stream integration allowed us to strengthen our standards based on science. And ultimately, the headline is to protect public health and vulnerable communities. And then this integrated data was also critical to building the air quality monitoring. And Madhav opened the session by emphasizing that really you need this modeling that brings together the monitoring, the emissions, the meteorological data to simulate the pollution levels and to test out different mitigation strategies. And really, it was this ability to test out these different mitigation strategies, control strategies, that allowed governments to decide on what the most effective solutions were. And it also allowed for this sort of tailored approach and not a one-size-fits-all approach. And then lastly, and sort of to me, again, most importantly, because this is a political issue, this is ultimately keeping the public on board, is EPA tracked outcomes. And in 2020, 30 years after implementing their strengthened air quality program, they've demonstrated dramatic increases in improvements on air quality. So, for example, PM 2.5 has decreased 40%, ground level ozone's decreased 30%, SO2 has decreased 80%. And this leads to then the next step of quantifying, well, what are the human health benefits? So they through their analysis tied this to a reduction every year of 230,000 premature deaths reduced, 2.4 million asthma attacks reduced per year, 17 million reduced lost work days or avoided, also millions of lost school days avoided, and this is every year. And then the last part, and this goes to sort of the economic analysis needed, is translating those health impacts to the economic value. And so these different health benefits translated to over $2 trillion in avoided costs and improved productivity through reduced work days, through reduced early mortality. And this is compared to annual compliance costs of $65 billion. So 2 trillion versus 65 billion. And this is a benefit to cost ratio of 30-1. And so at EPA, we always had to do this cost benefit analysis as the foundation, along with all the scientific studies, along with all of the analysis, volume of work, but always had to make this cost benefit analysis. And in order to do that, you had to understand the health impacts and therefore what are ultimately the economic benefits. And that's, I think, how we were able to get the public will and sort of keep the political pressure on. So I just wanted to sort of in a nutshell explain how the importance of this integrated data approach and sort of the what it allowed us to do. And, it's exciting for me to hear about how different groups are focused on different pieces of this puzzle. And then some groups are focused on how are you doing the integration.
Thank you very much, Laila. This is, some really impressive, phenomenal metrics that you have shared. 230,000 premature deaths avoided and more than $2 trillion for avoided costs versus $65 billion annual costs. So really impressive metrics, and hopefully we are able to kind of get to that stage of kind of bringing together both the cost aspects, the financial aspects, and the health aspects in looking at forward. Thank you very much. I'll turn to Professor Gufran Beg. So you have extensive experience in developing emission inventories, and you've also kind of more recently also started looking at these hotspots. Also, you worked on the forecasts. Can you maybe just talk a little bit about the criteria and parameters that you use to identify hotspots, and how can this information really help cities to mitigate air pollution exposure?
Yeah, good evening. So, for the paucity of the time, I will be just taking 4 to 5 minutes, very briefly, giving equal opportunity to leftover speakers. Because it's already 6 o'clock. So the very first thing which I will start with, you mentioned very briefly that emission inventory. Well, when I will ask about 3-4 points, I will conclude with some kind of a solution Government of India is working on. So with this, first is emission inventory. Unless we harmonize emission inventory and understand it properly, and methodology need to be harmonized, I think we are really very scattered. Give an example. In Delhi emission inventory, there are 3 agencies first suffer 40% transport contribution. One agency, TERI, it's about 12% transport contribution. IIT Delhi, 18% transport contribution. We are not telling that this is right, this is wrong, or this is wrong, this is right, but we need to find it out. There is a problem. Everybody has done great job in their own capacity, but the point is that we need to find out what we are doing it. So this is something harmonization need to be done. Unless if it is 12% transport contribution has to be made, I think we don't need EV. So why we talk about EV? So the point here is that you need to get into that harmonization. So the very first thing that we need to have some protocol where it has to be done. What is missing? I will come to that point. Then all this we are caring about climate change, air quality for what? Health and food security. These are the most important things we want. So our policies, our mechanism are taking all those, whether it's a data driven, model driven, observation driven, has to be health centric. And I think in our country it is still missing, although we talk about, but it is not health driven from that point of view. Very first thing we can always say that air quality index here, we talk about size of the particles. We do not take toxicity of that particle. So it is incomplete from that point of view. Many of us says that in Delhi, some of the PM particles are very good. They are good for our digestion because they are from minerals. But then in Mumbai, as you have shown that, we have already known that highly toxic particles are there. Black carbon, organic carbons are there. So, the point is, I'm not telling that PM2.5 is good. Don't take it from that point of view. But just telling that this is something which happens. Some PM2.5 is really good, which helps our digestion, minerals. So this is something where we need to combine size with toxicity to come out a air health index. And that is what would be the real service to the society in terms of their health. Then the most important thing is model for air quality models. So far people cop of thinking that it is really a big elephant and it is only required for the forecasting. No, our country, it is required for everything. Had it been a modeling related systematic effort other than the forecasting system, I think the kind of a smoke towers, 25 crores, hundreds of in a different we have done today would have been a different scenario. I think we would have saved that money and would have put it in a more useful framework. But then IITs were involved, big institutions were involved, and then that time Supreme Court was also there in that one, and then did it, and we did it. And today we know what it is. 150 meter, you are back to the normal. So there are a number of box model circulations done. But these are the kind of thing you require a sensitivity run. So it's not only to this, to keep you learning that if we do these, spend this, what would be the scenario and going to come into that. And we really missing this. I can see that Sarath, we have been doing, started in 2010 with the SUFFER. I think no other. So IITM continue doing it. Sarath continue doing, that's it. People are doing, publishing a paper, giving their personal biodata stronger, fine, that is all. But nothing more than that. So this is where, how we will contribute to the nation, this need to be. But who will tell? This is not your or anybody's fault. Somebody has to tell. I was having in a discussion, emission inventory, the two major factors, activity data, the emission factor. These two things are required. Then we are dearth of having emission factors. But who will tell? Emission factors in our country, IRI and other people have found out, they calculate only not because scientific community is suffering. because there is a BS3, BS4, BS5, so they have to commercialize it and get the money out of that. So how to ban or not to ban on this kind of thing, that is why. So you need to have tell to something. Activity data. We did not understand emission inventory even now only. We take a secondary data, how many two-wheeler, three-wheeler, Vahan portal, take out, equally distribute some of the people in the GIS, do it. There is no hot spot. All are hot spots. All are medium spots. There is no hot spot. There is no low spots. So this is where the problem is. And so then what is there? You need to come to the major roads, minor roads, do some kind of thing, you can have a framing. We did demonstrated with the drone-based artificial intelligence technology now, AI/ML. So that is where you are coming into that. You identify, you read this, read the plates, find out what kind of vehicles and all. And one of the results in Bangalore, we did it, 0.28% of the land area with 80 hot spots can save 25% of the emission for PM 2.5. This is the results. 0.28% of the area of 100 by 100 kilometer. If you take this kind of thing, identification of those. So this is something what we had to do. And then quality control and quality assurance. So that is the reason that about this scientist from HEI, whatever calculation she did it, I appreciate it. And in fact, this is what we could speak out. I also have that. We have done an emission inventory in SAFA 2010, 2020. Decadal trend. Decadal trend, there is a 8 to 10% increase in emission inventory, which is obvious. Vehicles from 2010, we had almost doubled. And technology which new, BS6 technology, 30 to 35% of the people, vehicles are using it. So rest of them are 15-year-old, 10 years old, BS3, BS2, BS4, all are there. So obviously, from where we have to find it out. So that way, all those there. But still, so air quality is certainly, even if it is improved, it is marginal improvement, 5% to 10%. But then take one of the years which is the lowest, something like 2013-14, subtract by 2024, say, oh, is a 40% increase, improvement is there. Statistical proper analysis is there. When you have done that, then you will find there is a 8 to 10% improvement is there, but with a rider that all kind of stations are available. If you remove it, it's almost, we are stagnant, at least we are not increasing. All those things, so quality control, quality assurance, all those system has to be there. Keeping all those things in mind, we need to come to an approach which in a National Institute of Advanced Study with the Office for the Principal Scientific Advisor started doing. There has to be a framework in India which should be science-driven framework. Science should drive the policy. Policy should not drive the science. And that is where we are lacking. So if we are having this kind of a system where there is a protocol that, yes, this is a standard methodology, protocols for the emission inventory development, nothing doing other than this. Put a data warehouse, you put it all those things. I think we will merge somewhere or other. There is no reason because all of us are scientists. Nobody is doing wrong job, but still wrong results are there. So then quality control and quality, somebody has to tell that thing. Emission factors has to be worked out. Somebody has to tell that this need to be funded. Then only it is done. And this is a big research, basically. It requires a lot of money with the activity data, how you have to generate. You can't have a just GIS and put a kriging techniques over there and distribute your emissions just like that and claim that it is 1 kilometer by 1 kilometer, 100 meter by 100 meter and all. Keeping all those in mind, we had to start, number one, with a optimized our approach, airshed approach, where whatever Delhi is doing efforts for last these many years, almost not seeing any kind of improvement. Whatever the improvement you see that 8 to 10%, that is all because of that grep, because time limit is not because of the emission is declining. It is all because you are forced during those days, which is being done. That thing will never improve unless you do all those efforts in an airshed mode, airshed area. An airshed area is the area where there is a shared metrology, shared transport, shared emissions. So compensating here and there and all. Everybody says that many people believe it, most of the emissions or pollutions coming from outside in Delhi, but you do not know that well, Delhi is sending out, other people are sending pollution to inside, but Delhi is also polluting outside also. It's not that Delhi is stagnant. So there is a two-way exchange is there. So you cannot say that it is like this. Still I feel 70 to 80% here, but things keep on changing from day to day and all. Keeping it in mind, we should have a kind of a framework which is a airshed based framework, whether it is Sarat develop it, I develop it, somebody else develop it, let us come to the time, but something like 15 to 20 airsheds are there, which is we all are agreeing, and there should be a shared methodology. There should be, let government put it, one air quality manager who should be responsible for that, implementing this. We have to forget, because as the pollution do not regard the administrative boundaries, political boundaries, government boundaries, from one government to another, this is what government, it has to be shared thing. For example, Delhi airshed involves 7 districts. These 7 district people, 7 state people have to come together, work on that. We should have a responsibility person. But there is no policing or something is required. Automatically things will be in line. They have to advise people. They have to do that. CAQM is there, but that is their mandate is up to Delhi and surrounding region, who will look into the country. And then there are several things which requires additional several things which doesn't require at all in other part of the country, as Delhi is requiring. So airshed approach, other things approach has to be very different. It is different. For example, if you see in a national-wise, biofuel emission is a dominant emission source for PM 2.5. Delhi, 40% is a transport level. So we all think that transport is the culprit and all, but you look at it, 72% of the population is in the villages. So obviously, still Ujjwala scheme has dented greatly, but we are coming back to that because of socio-economic factor. So probably if there is a success under the aegis of the principal scientific advisor and under the ownership of Ministry of Earth Sciences and Ministry of Environment and Forest and Climate Change, some efforts is going on, where a science-backed framework, what we call is a National Air Quality and Climate Resource Framework, probably can come before NCAP 2 get formally formalized. If all things goes well, then we will have a science-driven approach, and where the emissions are the key. It's not source apportionment with the key. Source of a very good scientific terminology, very good scientific work, but source emission inventory, where it is a static quantity. You are emitting this. You can pinpoint that. In source apportionment, you can say that no, in winter we do not contribute, only we contribute in the summer. Summer we contribute not. I mean the point. Here it is you don't have to talk to anyone all. You are emitting this, nothing doing. You either you are polluting yourself or you are polluting someone else, but you are emitting this much. You have to take that. So for the policymakers, for the mitigation strategies to be framed, it is an emission inventory which makes a sense, which is going to have that. And then if we come with a standardized methodology, standardized system, accuracy of the activity data, we can have our own emission factors. There is no reason that we cannot come out with a uniform results. So all those things is taken care. Whatever I talked about, this has to be there. If this kind of a framework comes, science-backed framework, I think we are in a good shape. Our efforts would be divided, I am telling, by 1 by 10. Whatever CAQM is doing now, they have to do 1/10 of that work to yield the similar results which they are getting now. So with this, I think I stop it. Thank you.
Thank you. Thank you very much, sir. Very insightful comments there and points mixed with humor. So it's very, happy to hear you speak. But you made some important points about harmonizing and, the EI emission inventory, need to look at toxicity in addition to the size. And also the statistics about how a very small area kind of contributes to almost 25% of the emissions. So let me now switch to Dr. Sarath Gutikunda. You also have extensive experience working with the activity data, kind of really taking all the secondary activity data and applying them for emission inventory. I have so many questions to ask, but maybe I'll just focus on one thing, maybe looking at, how can we make this data easily understandable and usable by cities, and how best can cities update these data regularly? Because these activity data, generated for or whatever the surveys are collected for another reason. And very few people, such as you, Professor Baig, and few others, actually know how to apply that data to assess emission inventories. So how can we enable cities to kind of begin using the data? What is needed? So any thoughts on that?
Hi, thank you. I think some of the points that I also wanted to discuss align very much with Baig's work, and so I'll focus on one thing. When emission inventories work is not about pretending that we have the right answer. Main challenge being data that we use is secondary. It's always been secondary. Whichever country we go to, it's always secondary. Because the primary part of the information that goes into that methodology is only the amount of surveys we can do, or amount of evidence that we can collect, or amount of lessons, the lessons that we are learning from applying a certain methodology, then we're scaling it up. Okay. So even for the example that Gufran has mentioned, so a small percentage of area is contributing to a lot. And then we are taking that lesson and going to expanding that to the entire city. Ideally, if we really want to do an excellent job, every square kilometer we want to monitor. It is not possible. So the amount of evidence that we're collecting is at the hotspots, and then we take that lesson and you expand that to the other areas. I think when we collect that evidence, if we can make that into an education tool, then the format of scaling up really makes it an easy process. A very simple thing is having a tool for, let's say, transport sector. There's been a lot of discussions today in the sessions earlier. We need the number of vehicles, so you can go to the Vahan website and download that data. But you need a certain survey done to understand whether those vehicles are actually on the road or not. Some survey has to be done. So if an educational tool can be put together on how a city can do that survey themselves, so it doesn't have to be a very elaborate process that will take a year or 2 years. So there are ways to do it in like a week or 2 weeks. So if we can, but that part has to come in that education part. Okay. And the same thing with the emission factors as well. If we actually go through the process, it's a very detailed, time-consuming, very expensive process. But from the top, from the institutional side, if PUCs can be strengthened, then we actually will have that emission factor information. So right now, every vehicle gets a test done. This is a point I made earlier in the morning as well. Every vehicle gets a test done, but none of that information can be used for this emission factor building or using it for any of the inventory work. Now, so we have the system in place, but that one piece that we can add, it helps the research community a lot. Okay, I think that's where the data challenge is coming in. Okay, and then again, there are a lot of other activity data as well in every sector, in transport sector or domestic sector. Still, we rely on the census information only, but if surveys can be modeled or even manipulated a little bit with some kind of on-ground training, I think we'll have a lot of information. Okay, yeah, I'll stop there.
Thanks, Dr. Sarath. So totally agreeing. Okay, so now moving forward, I would like to ask Nimish Singh. So we talked about the challenges Dr. Sarath told and Dr. Baig also. So I would like to know, what do you think institutions like TERI and WRI India, what role we can play in making air quality data more accessible and understandable for citizens and the communities?
Thank you so much. First of all, I would like to correct one data sets. Being TERI, I think emission inventory talks is done and our name comes up every time. So 40% is actually Delhi's contribution towards transport pollution. And it's now, I think, 46% at this point of time, which was the last inventory that we did. Over and above, I think now going back to the what we can actually do and what we have been doing, we are not exactly a research organization or a consultancy. We work both Terry, WRI, and similar organizations work in between both of these areas. So we are actually the knowledge breakers. The scientific community or the researchers that we are actually delivering can be converted into somewhat of a layman language, which could be understood by the policymakers, and not just the policymakers, but also by the citizens. So that work, if we are actually able to do pretty easily and deliver it, most of these information which is being generated at the research level in terms of concentrations or emissions. I think one of the basic issues that I've actually observed while discussing about air pollution is most of the people don't know the difference between emissions and concentrations, right? And the media or the public are sensitized based on that half-hearted information of what it is actually they are actually talking about. So the work that we actually do can put these things into perspective and making those informations actionable. Once we are actually able to deliver that kind of information, I think the data collection might actually get better, because at this point of time, if the information or the required data sets which is required for developing the emission inventory is not understood by the people who are actually collecting it, because those are different departments. It's scattered across different departments. PCB is one department, they actually understand it, but in case of transport, it resides with RTO. In case of waste burning, it resides with the local government, while other data sets are similarly dispersed in different directions. So the work of Terry and WRI could be bringing all those data sets together onto a one platform and making it easily accessible for the actionable intel to PCBs or CAQM or similar kind of organizations. So that is the work that we can actually do. Further, we can also build capacities of citizens and policymakers, making them also a stakeholder towards this collection and making this fight against air pollution more and more doable, for not just in terms of table talking, publishing reports, or just giving inputs to the government, but rather taking the things to the ground and making all those things actionable. I think that's it.
Thanks so much. Okay, so now moving forward, I would really like to understand how can we employ the different tools for real-time detection and action. So, Namita, to you, what do you see as the future of low-cost sensors, and how do we apply it for near real-time source identification to support on-ground actions?
Okay, now you can hear me. All right, excellent. So I think low-cost sensors really sort of help with hyperlocal monitoring. And, so far they've been used for driving awareness amongst the public, behavior change, local mitigation, like, for example, automating smog guns based on air quality, local decision-making, like when people should go out for a walk or when they should stay indoors. But what we're starting to see is, much sort of deeper functionality that's coming out of low-cost sensors. So some of the big sort of trends I'm seeing, one is, more effective data-based enforcement, like BMC, recently launched their sort of requirement at construction sites. Similarly, DPCC has this enforcement. I think this is really opening up the opportunity of more data-based enforcement rather than, the winter bans that we're doing for construction, for example. And I think it's only low-cost sensors which are enabling this sort of solution, because, sort of deploying regulatory-based sensors for such solutions is pretty much impossible. I think the other thing that you talked about, RTSA or real-time source apportionment, what we're starting to see is that the sensor quality amongst low-cost sensors is also improving. So now, in addition to laser scattering sensors, we have OPCs, right, which have significantly more bins as compared to laser scattering sensors. Now we have more reliable gas sensors like CO, SO2, NO2, ozone, which actually allow co-location with regulatory grade sensors and building models so that we can actually build models for real-time source apportionment and then deploy them in real time and actually understand what the sources are, so that more real-time action can be taken. Professor Beg also spoke about air sheds. I think with local, with hyperlocal monitoring and large scale distribution of networks, it is, much easier to start now understanding air sheds. So these are, and then finally, actually, is personal exposure studies. We've been working with AIMS and ICMR, who are actually now using low cost sensors for personal exposure studies for pregnant women or people with asthma to better understand the effects of air quality on personal health. So I think, there's some really sort of strong use cases of low-cost sensors that are coming up, and I think this will become really valuable in fighting air quality in future. I just want to call out a few things that, we absolutely need for this to work, right? One, we need central certification labs where these sensors can be validated. Without that, the government has struggled with adoption of these sensors. BMC sort of launched this process of validating at one of the IITs, right, which has been a good process, but we need a stronger certification, certification source here, right, where sensors can be certified in a more sort of stringent way. We need strong partnership between industry and academia because we have to continue to work on, accuracy and calibration of these sensors. We need more recognition from central governments for these low-cost sensors, which has really sort of prevented the adoption of low-cost sensors, which, in a country like India, honestly, is the only solution to creating the kind of data that we actually need to make change. And then, the last thing I just want to call out is the need for central dashboards. I feel like, the data right now is extremely fragmented, right? Like DPCC has their own servers, BMC is building their own servers, TMC is building their own servers, Ahmedabad is building their own servers, right? We really want to get, there's no need to sort of duplicate all this work that is being done, right? There should be central servers which are built where all this data can go. Central systems can be built for recognizing, where sort of construction sites are non-compliant. We can, and there's so much monitoring data that is being produced from all this industry. This can be, integrated with the CAQMS data and actually help increase the amount of monitoring we have in the country and start building more models, and also actually fill a lot of the gaps that we have in the CAQMS data where large, like for example, in Haryana right now, there's not a single government monitor which is on in Gurgaon, right? Because they have some tender issue going on, right? So all this, the low-cost sensors, which are being set up already across the country, right? They can help fill a lot of these gaps. So thank you.
Thank you very much, Namita. Very important points about needing for a central certification body, and also, you talked about this how LCS is kind of being pushed, to test its limits in terms of using for real-time identification. So that's really important. Now I would like to turn to Dr. Sumit Sharma. We've heard about these different data sets, the limitations. And we also we just touched upon a little bit upon this real-time source apportionment. So you worked in this chemical speciation and source apportionment work. What is the balance between, let's say, these periodic filter-based source apportionment studies that we do and real-time source apportionment methodologies, which now is at the stage where we could potentially deploy these low-cost sensors once these models are developed, and how policymakers can use them for short-term actions and long-term planning?
Thank you, Prakash. It's a learning experience to hear from Dr. Beg, Sarath, and fellow modelers. We need to, make one consensus that there are several modeling approaches, receptor-based modeling approaches, which you talked about. Either you do it through filter or you do it through real-time source apportionment using statistical techniques. And on the other hand, you have dispersion-based models. All of them needs to be used as complementary exercises and should not be seen in isolation. The problem with the source apportionment study, which I have seen over the last 20 years, is a lot of them just focus on one exercise without getting it validated through the other exercise which can be done. The classic example is you do it through filters at some locations in some cities for a very limited period of time, and then you basically start taking decisions on that basis. on the other side, you sometimes do dispersion modeling, but you don't compare the results with the receptor modeling to have a good validation of the data sets. Once that is done, then you have more credibility of the data which is produced, and based on which you can turn the knobs of the dispersion model to run various scenarios, because your model is absolutely validated with the species based or filter based source apportionment. And the point which Dr. Baig raised, emission inventory is a very, very crucial element. And unless we have standardized methodologies, and he's right, several times you will see that there are differences in emission inventories. But several times which I have observed are the issues which are related to the interpretation of the results. For an example, when you're comparing receptor with the dispersion-based source apportionment, you will find that the receptor is telling you 30% is secondary particulates. Now, unless you divide this 30% into sectors, you will never be able to compare dispersion with the receptor results. And then we tend to believe that two approaches are not matching. So I think these kind of things need to be seen. But to specifically answer your question, both filter-based and sensor-based approaches are important. And the sensor-based, of course, can provide you more continuous data. Filter-based is a one-point data you have. But to validate it over a period of time, you need filter-based measurements, and that is to be done at certain locations. But as we all know, monitoring is extremely expensive. You need to have validated dispersion models, and ideally, we have seen this movement over the last 20 years, people moving from normal diffusion-based models to chemical transport models. That has to be done, which will allow you to spread this point-based information of the sensors to the whole city or to the whole region on a spatial basis. It will also allow you to see into the future. Receptor model can tell you what is happening now, but dispersion modeling can tell you what can happen 5 years from now or 10 years from now. And of course, if you need to get into sub-sector distribution of contributions, and that is something we're missing gap in the source apportionment. We always say, vehicles 25% contributing. Which vehicle? Which type of vehicle? Within that category, is it the whole, all kinds of vehicle in that category are polluting, or there is a sub-sector which is contributing to 98% of the pollution in that category? That can only be done through good emission inventories and converted into source contributions. The last thing, which in my opinion is very important, and I think again we have come a long way as modelers to differentiate between local and regional contributions. A significant part of contributions in cities is coming from regional side. And despite whatever you do in Delhi, you stop all pollution in Delhi. We have seen during COVID, most of the city was blocked. Still, we were violating the standards. What was burning? It was coming, a lot was coming from outside. It still comes from outside. So along with what you are doing in the city, you have to take widespread measures. And for that, I think we need, regional scale or airshed based approaches. My last point in this direction is we have National Clean Air Program at the national scale. We have city level, programs at the city level. Air quality management planning, but we do not have strong state level air quality management plans. And once you have that in place, or ideally a regional based plan with integration of some states who can join hands, that can basically resolve number of issues which can only be dealt at the state level in terms of policies. If you need to target industries, state level departments need to come into picture. Agriculture, if you need to target, city level can't do anything. You need to target state level agencies. And that's why a scientifically developed state level action plan or a regional level action plan in an ideal condition is a must. Thank you so much.
Thanks. Thank you very much. Some important points there about how to really balance this filter based versus the the low cost sensors, as well as how do you really kind of needing to use both as complementary measures approaches to understand and validate each other. So I'll now turn to Mr. Sriram Manogran from Clean Air Fund. So for any of this work to be performed, obviously there needs to be sustainable funding and long-term vision. So Clean Air Fund, you manage the data portfolio. So what type of data initiatives Clean Air Fund envisions being important for the next 3 to 5 years?
Thank you. So for the last 1 hour or so, we've heard a lot about where the air quality sector is in India, what kind of data we are producing, what kind of data do we need, and what are the steps we need to take forward. I think most of what we spoke today are in focus with Clean Air Fund, but there are limitations to it. So Clean Air Fund is a re-granting organization, so there is limited amount of funding that is available, and there is strategic focus on what we can do. To give a small introduction on the strategic focus, our 3 main goals with respect to data globally and as well as in India is to generate data. So we're talking about generation of data globally. That could mean PM 2.5, concentration data, as well as emission data. That has been more generation of concentration data with the help of low-cost sensors has been a much successful program outside India. But in India, we have some guidelines and limitations to it. So we look for ideas on how to improve the data, how to generate data that would be useful in the local setting. That could mean a lot of emission data. We spoke a lot about dynamic emission inventories that needs to be updated in city-wide operations or at the national level. So that is one of our focus. To move away from static emission inventories, what are the opportunities there currently, and what are the initiatives that are already happening at the moment that could be incorporated into city-level plans, and that could inform the city stakeholders what exactly is happening with the emission inventories. How dynamic are they? Are these emission inventories, are the current emission inventories actually being helpful in informing the stakeholders? If that is good, then we would definitely be interested to understand how can we improve that system, because not one size doesn't fit all. So when we take move from city to city, a city like Delhi with a lot of information could have a very rich dynamic emission inventory. But if you move to a tier 2 city or city away from Delhi, which does not have a lot of air quality focus, they might miss, that city might miss a lot of air quality data, both concentration and emission. So for that kind of a city, we don't need a dynamic dashboard. You can use a static emission inventory. So that would be one of the priorities for us in terms of data is concerned. Another data idea that we are interested is also looking at satellite data and gridded data sets. These are also, there are some successful case studies in the last few years, especially within the Clean Air Fund, in locations outside of India, in geographies like Africa and in Southeast Asia and South America, where we have looked into gridded data set as an opportunity to see how that can fill in the gaps national wise. So for instance, in one of the African country of Ghana, which has only like 3 air quality monitors, 3 reference monitors is all they have, and they have improved in their air quality network with low cost sensors. But that's also very city bound. There are a lot of pollution that are happening outside the city. Even though it is a small country, there are pollution sources from city and rural areas would be different. So a gridded data set was useful there. So we would want to explore that idea in India to understand, is there an opportunity for satellite and modeling data in India in places? Because we spoke about how big our country is and we cannot install low-cost sensors or reference monitors everywhere. So is satellite data opportunity for us to look at? We also, Namita spoke about the need for unified data platforms. So Clean Air Fund supports organizations like OpenAQ, who basically does the job of a data aggregator. OpenAQ exists because many countries globally don't make their data accessible for all the communities to use. In India, the challenges is much more bigger. There are different bodies that are owning the data. So we definitely want to see what are the opportunities to come up with unified data platforms, maybe at the state level, because bringing cities together in one state would be useful, and that could help in setting up a platform for a national level data platform. The second pillar of work that we do at the data portfolio is supporting cities understand data better. So we've generated the data is already there, but the city stakeholders are not able to interpret the data and take actions on it. So we've invested in a lot of tools outside of India and within India as well to break down the data into information that city stakeholders can absorb and take action. There is the advent of AI and machine learning has given opportunities to like maybe give them a data management system that could just with a click of a button will tell them, okay, there are 100 low-cost sensors in a city. How many of them are actually functional? What is the downtime? These are things that could be automated. What is the hotspot analysis? Where is the hotspots? So these are some of the things that could be quickly done. And these are the initiatives that we want to look at the city level, at the state level, that could help the capacity building issue that is existing right now. With automation and with AI tools, we want to see what we can improve in making air quality data more effective. And the last point area that we work on at Clean Air Fund within data is standardization, which has become a global problem. Like an example of what has happened in India as well is like we have a big rural air quality data network, which has both more than one air quality sensor provider. So bringing all the data into a data management system, it is an issue because the metadata, the framework, the formats, they're all different. Then you bring in satellite data, the reference date monitor data, bringing all of them together makes a lot of work. And that itself will set it up for a failure to bring data together. If you're not able to bring data together, and then that creates more problem for people who can actually take actions on it. So we want to work within the communities, sensor providers, to understand how can we standardize the formats. Namita also spoke about certification for sensor programs. So there is a sensor program called the AQ Spec in America, which is actually semi-private and a government body which actually runs a sensor evaluation annually and provides data of how the sensors are performing in that location. We've replicated that program in Africa and in Southeast Asia, and recently in India as well. C-STEP has taken that to set up a sensor evaluation. So C-STEP don't have to be that India sensor program. Like C-STEP, a lot of other academic organizations can run seasonal sensor evaluation programs, ask manufacturers to send their sensors. They can do the evaluation, publish papers on it. It is a good exercise for academics, and it is a good amount of data that is needed for all the think tanks and the governments as well. So these are all the initiatives that we think would be really useful from the data point of view, and that would make a really good impact for the funding that Clean Air Fund has in the next couple of years.
Thank you so much for sharing. Because this was some very happy to see that the discussion was kind of somewhat aligned with what Clean Air Fund is also thinking. So we are in the right direction, and hopefully we can, as a community, kind of start developing these things. I want to check if Subramaniam sir is here. No. Okay. So no. Okay. Right, so I think that brings us to the end of the session. If anyone in the audience has any questions, if not, I'll turn it over to my colleague to do closing remarks. Thank you. Sir, do you want to take the question?
2 lines answers it, both the questions of that. First one is, it is not only the point source. There are 3 different kind of sources are there when we develop emission inventory: point source, area source, and dynamic source. And there will be hot spots where you have a point source, but then it will get dispersed, so it will continue with that. Dynamic source, you will have again based on transport, and area source, that many areas are there. So this is the answer of that. So it's not that simple. It is very well taken care as per the atmospheric conditions. Second questions, your was airshed related, right? Satellite. See, satellite data, certainly whatever you said, it is perfectly okay. Two important things in satellite. Firstly, so far we do not have a effort which can dedicate for the air quality services. The kind of a satellite product what we get it. Those satellite products what we get it, they are basically, specifically India program I'm talking about, basically for some other purposes. So the kind of a parameters what we got is a indirect parameter like aerosol optical depth or something. All those. So I think we need to make full utilization of those. We should have to have a different, our own satellite specifically dedicated to this kind of a services. But whatever we are having at this stage, I think we can drive lot of leverage out of that. But that work need to get a prominence. Slowly people are doing it. But I think a lot of, training works are also going on, which I see. But then we need to optimize that, and people have to tell that how to use it, satellite data, for the purpose, focus purpose we want.
Thank you.
I think
to that, Gurpal sir. See, in Mumbai, the pollution comes generally from Pune, where you were situated.
Right.
So that's just a transboundary pollution it comes. So Mumbai, there may be local emission sources, there may be local pollution, but the transboundary pollution comes from Pune side, that is eastern side of the Mumbai part. So there we need actually to understand what is this transboundary migration or movement of the air, and that can be captured through satellite. So we have tie-up with IITM in Mumbai so that it can forecast 72 hours before that what would be the pollution coming in future to Mumbai side or around the periphery of the Mumbai. We have a MMR region. So there are many construction activities going on in Mumbai metropolitan city. So that pollution also get transferred to Mumbai. So such data can be captured through satellite or the local pollution source, this CQMS stations or something like that. So that is how it will help us to get the right data and the right action to mitigate that.
Just want to call out that, it's not so easy to use satellite data for ground level monitoring, because with satellite, you get the data for a vertical column, right? So you actually don't know how much of that pollution is ground level, what people are breathing versus, along the vertical column. So while satellite data can definitely enhance the air quality inventory, it is not sufficient. You need ground level monitoring in addition to satellite monitoring to really understand the ground level realities.
Since satellite data is too expensive, so we cannot handle this. Continuously, we have to handle the data. So as a thing, we can come across the city wherever we can find the drip permit, and wherever is possible, we can monitor through that air quality circle. Continuously, we have to monitor. Systematically, we can do it, and we can share the data. And by the time we can give the trend analysis also, we can give the awareness, and also we can forecast. We can, as he said, so periodically we can give the forecast. Every day we can give the forecast to create the awareness, as well as we can give the trend analysis to avoid all these things, that comparison between that legacy data. So you must have the big data analysis also. So in that case, we can use it. But as far as my concern is satellite data, I don't think whether it is possible or not, because it's not affordable for that.
There are satellite data sets that are freely available. Some very high resolution. We need to pay.
High resolution, you have to pay the
Right.
affordability that you have to say. Nobody will
Right.
find.
So it depends on the application for which it is used. But anyway, I think Dr. Vikas Singh wanted to make a point, and with that we'll close this.
Yeah, so many points are already discussed here. That satellite data has its own limitation because it measures the vertical total column. However, satellite data is extensively used in air quality management globally as well as in India. It is not that satellite data is not used. Satellite grid products are already used. It is the inference that we have to make from the satellite data, and they provide great detail. Again, coming to the pollutant, when you say pollution, it is not only PM 2.5 or PM10. For particulate matter, there is an issue for the vertical column because there is a lot of regional transport, so it doesn't depict the surface level monitoring. But if you go to the short like lifetime pollutants such as NOx, it can depict, and then the Tropomi and the Yamaki other satellites give exactly the hotspot. In Delhi, you can see the thermal power plants, you can see from that. So it is extensively used, and a lot of research is going. Those kind of data is already assimilated in the models. So the data assimilation is not discussed here. Data assimilation is a fusion. In the simpler language, you have the emission inventory, you have meteorological models. In meteorological models, lot of data goes, satellite data goes. Then you have the air quality model, where the data is assimilated, satellite data as well as surface observations are assimilated to give a final product. That is sometimes called reanalysis product. That is extensively used for meteorological prediction as well as for the air quality management. Coming to your second point about the industrial emission. The way the Pollution Control Board or the CAQM looks at the problem is much more complicated than what is discussed here. I think already Gujarat Pollution Control Board, Mr. Irfan Kagzi has mentioned that each and every industry is recorded. They are given license. This consent to establish and consent to operate is given. And then the polluting industries, whoever is there having stack, they are mandated to have the OSEMS, Online Continuous Emission Monitoring System, which is regularly monitored by the Pollution Control Board as well as CAQM. Whenever they exceed the emission limits, the automatic alarm is generated and the industries are inspected by manual monitoring. So there is a process to control and mitigate the emissions coming from various sources. So we are working towards the data-driven management. Slowly, the data, we agree that it is scattered. Data are getting aggregated. CAQM has already given recommendations for this database management, where all data is going to be aggregated. Common whatever integrated command control centers are going to be set up. So slowly, we are moving towards the data-driven approaches.
Okay, thank you.
Prakash,
Can I make it 10 seconds? 10-second interventions?
So just with using the simulation, I think in Delhi we can create that digital twin model.
No, I think we are running out of time. The facility people are there ready to kind of occupy this. But Sri, do you want to make some closing remarks?
No, I mean, I think it's a very rich discussion. I mean, very difficult to capture all of this. I've tried to capture this as 10 key points. I think one is this: understanding the trends of concentration data is really important. Understanding in a timely way and using it for governance, right? So I think that is very important. We need to move beyond the static inventories, right? This is going to help. How do we do that? So the second is that activity data, right? The activity data, whether it is industry of all of this bringing it together, deployment of measures, deployment of measuring systems, ensuring that we are able to use the data in a timely way. Then interconnected central unified data platforms at various scales, and looking at how this can be used for governance, right? So data assimilation methods, how do we actually take it into the usage part of it, and then understanding tools, data tools to understand and make useful of data. I think this interesting idea of hotspots and how that understanding of hotspots can make a big difference. Then modeling. I think this complementarity of modeling came up as a very interesting and important different ways of modeling, but complementarity. Then need to standardize and harmonize EA preparation. Not only that, it is also standardizing the emission factors, standardizing the data quality itself, and so on. Airshed-based framework, which can help in regional-based approaches. hyperlocal monitoring, this is going to help in not only in various ways, right? Better real-time source apportionment, better control of regulatory measures, exposure studies, several things can be done. Of course, if we need to do it, deploy it carefully and very successfully, then we need to certify the sensors. We need a governance system for it, how to ensure that we are able to certify it. And data is not about only, the particle sizes and, it actually the toxicity, which is the matter. And therefore, the health-centric study of the data is the matter. So with that, I close that. Yeah.
Thank you. Thank you very much, Sri. Thank you all for staying so long and, kind of really participating in this engaging discussion. Yeah, we are quite fast behind time here, beyond time. So thanks again. And I do want to kind of acknowledge the team behind this, Ritesh, Shruti, Vandana, Sanjay. They have all worked behind the scenes and kind of really conceiving this whole session. So thanks to all of them. Thank you all.